This subVI will extract the message portion or the data block portion of the FSK demodulated bitstream. I'll do some quick steps here to create the bitstream input. And you don't need to do this for your version of the subVI, but I'll make a demonstration front panel control. And that way I can key in some specific values for the Boolean array, and that'll help to explain the general idea of what we're trying to accomplish here. I'll go ahead and put down somewhat random sequence of ones and zeros, and then next a region where we have a series of all 1 values. Again, I use 1 to indicate the true version of the Boolean. And that corresponds to that region which is called the steady mark region just before the data block starts up. Alright, the for loop structure will then analyze every single element of this Boolean array, and it does so starting from the beginning of the array. So as it goes into the for loop structure, we have just one element at a time. The multiplexer or data selector here will give us 2 different options. One, what I'd like to do is anytime we see that the input value is a false, corresponding to a 0, then that's going to essentially clear out our running sum that I'm forming up here on the top. So the idea is that if we encounter a true, we want to increment that value. So we're trying to count up the total number of trues that we see in a row. And any time we go back to a false, then we clear this count back to 0. Now I'm trying to get an array as a result here, and you'll notice that the output so far from our for loop structure is just a scalar value, so that's not actually what we're interested in. Instead, if we use a for loop tunnel with auto indexing turned on, which is what we get by default, then it accumulates every single value that's generated on each pass of the for loop structure. So let's take a run here. And again, the idea is if we have multiple ones in a row, we start to see the values getting larger. Anytime we have a low value or a false value, we clear it back to 0. So here we see we have this relatively long run of ones. The values get larger and larger. So the thing that's really of interest here is the largest value, largest non-zero value, and the point just after that is where the caller ID data block starts up. So I'll suggest the min-max array device here, and it can report both the max value that it found as well as the location of that max value, and the same is true for the minimum values. So in particular, it's the location that you will find of interest. Next, another device in the array palette that I draw your attention to is the split 1D array. So again, you know where you need to separate off the caller ID data block, and the split 1D array is how you would actually fork off that value from the original. Again, just remember that the demo that I was looking at, you don't need that one.